Oh, surprisingly, not surprisingly, we've gone live, and I'm just now seeing it. Okay. Well, hey, everybody. And it's playing back at the moment. Okay. Take 3. All right. So, anywho, welcome. It's been a minute since we did one of these. It's been through the holiday season. I'm really happy to be back in action. We've got some really exciting things in store for OPIA. The community is growing, as you will see. We've got some great speakers for you today and some exciting features that were added to our release 1.2, which was released a week or so ago, a couple weeks ago. And exciting to see everything really take shape and the community build around this. So I am going to share my screen. So one moment, please, here. Okay. So I'll give you the update. Let me pop this into. Okay. So, super brief for those of you who are new to OPIA, so the Open Platform for Enterprise AI. So, the idea is, as we know, GenAI is everything right now in technology and in the world. And so, what OPIA aims to do is present a framework of composable parts. And the reason it does that, and the reason we're aiming at enterprise, is that basically understanding that you as an enterprise probably have been using different pieces, have vector databases, favor different LLMs, and that you wouldn't necessarily be starting from scratch. And so, how do we give you something that can work with the environment you're in? How can we give you something where you can make choices that make sense for you, right? So kind of taking something that is frankly going to be complex no matter what, and trying to put some ease into it if we can. So the other half of that is that we have these blueprints that I will showcase later. And I will tell you, most people are looking for chat Q&A just to get started with, right? It's like an easy kind of understood need in business. It's an easy way to sort of dip a toe into the Gen AI ocean and see what sort of benefits and outcomes there are. But we have a number of them, and we're at the point where it's less about adding blueprints, but enhancing them and improving them. So there's definitely a lot to look at. And then there's the evaluation side of things, which is really super fast moving and really interesting at the moment, in terms of people need to know how to assess their different systems, how to evaluate LLMs. And that's really difficult. And so that's an area where there's a lot of work going on. And hopefully some of the end scenarios are making it a little bit more simple to walk through that area, right? And understand, if I need something that is super secure but not necessarily like the fastest thing in the world, maybe here at OPIA we can give you that, right? We can point you in the right direction without you having to go back and figure it all out yourself, right? So it's been really fun this first, I guess it's only been about 9 months. So let me tell you about the latest and the greatest. So we have so 1.2 dropped. This isn't just about that, but so that dropped like I said, a week or 10 days or 2 weeks ago. And so the great news is now that Llama Index and LangChain integration are fully enabled as a backend. So those are great. We have Haystack on the way for 1.3 release, which I think is going to be in April, which will be our 1-year anniversary, and more about that soon. So that's really great. Those are known quantities and frameworks that people are using. And so, like I said, one of the things that this OPIA enables and open source enables is that composability, right? And being able to modularize and use the things that you're using. So that's really great. I'm proud to say, have actually 53 partners at the moment, and that continues to grow. And that's fantastic in that, a project is only as strong as, the community around it. So this is a healthy community. We're looking to get more and more participation from all of the different partners. And I think it bodes well that as part of the project, we need that modularity and we want all of those different partners because it's sort of like plug and play. So Opia is available in the AWS Marketplace, and I'll put some links after I'm off into the chat so that it's easy to go and check these things out. But we know people are, developers find themselves in the different cloud service, marketplaces, right? And so we started with AWS. Opia is available in there for free. We plan to have it in Azure and Google GCP next, and then we'll go on from there. Right at the last minute, as part of the 1.2 release, we got Bedrock into Opia, which is really amazing. The Open Search Foundation joined us as a partner, and Open Search is now compatible with Opia, which is fantastic. Really excited about that. Infosys has been super cool to work with. They've been a key contributor in this sort of round. They're working on Azure automated deployment, and they've also worked through integration of Elasticsearch. So that's really good. So we've got a lot of different vector database integrations. I'll just say sort of generally, Opia awareness and adoption is growing. We've had a couple of companies come to us looking to replace OpenAI with something different. And in a couple, I think I might be able to announce it, but I'm not going to, just because in case. But stay tuned for a company that has done that with us. That's really great. So we're having more and more, we're seeing end users that we'll be able to talk about soon using Opia, and hopefully that will be really insightful to you. AMD has been another amazing partner, and they had started to validate a lot of the blueprints in Opia 1.1 back in November, and they've just continued plowing through all of those. And so pull requests, up and down GitHub with this, and that's been really great. So, and they're going to be speaking today, so that's really great. So Opia is, more and more hardware agnostic, so that we're really happy for that. And then the two announced sort of companies that are going to have appliances that are powered by Opia are Dell and H3C, and you'll see later there's links. And again, I'll throw some links in the chat so that we can take a look at them. So this is a little bit of the different highlights. So like I said, it's not so much that we're adding, new examples, but we're making sure that you can do more and more with each of the examples that we have. So like I said, chat Q&A is by far the most popular. So we're getting VLLM, into that. Then agentic AI is on the rise, as you all know, if you're somebody that's listening to something like this. And so we're working on that. Multimodal is great. DocSum and Doc Integration Retriever, adding stuff there. So that will continue throughout the year. You'll see that. Like I mentioned, OpenSearch is now a component that you can use. Elasticsearch is a component, and we do have some new guardrail hallucination detections. Like I said, we're working towards the Azure automated deployment, and it's a new day, new model. So we're adding more and more models every time. And then, like I said, we have hardware support for AMD and now Gaudi 3 with Intel. This is just a quick look at all of the different examples that we have, and you can check this out in the repo. Take them out for a spin, see what's going on, and just highlighting which ones have been enhanced. So then I like to look at this. This is near and dear to my heart and what I work on. So in April, all of these numbers were 0. And so this is where we're at right now, which is fun for me to see. So GitHub followers closing in on 700, if not having reached that by now. This is a week or so old. We've got some stars going on our most popular repo, which is the GenAI examples repo. The numbers keep on going up by the thousands on opia.dev, which is really a great place to look. You can check out what's coming up in terms of events. We're really starting to try and blog every couple of weeks there. there's it's sort of the gateway to the wiki for any sort of like open source stuff, old events you can find there. And we do have a lot of technical documentation right off of that as well. Last year we had a bunch of virtual events. A lot of people registered and came to those events. Hopefully that's the same thing this year. So our next event is actually going to be in April, and it's going to be sort of like a global. It's going to be 3 days, 1 day in sort of a different geospace, and celebrate sort of 1 year with OPIA. So more on that very soon. And definitely, if you're listening and have experience, have contributed, have something to add, and want to be a part of that, reach out to me on LinkedIn, or you can email me. I'll put my email in the chat. Definitely looking for people that have used OPIA, that want to use OPIA, or that are contributing. That's great. And like I said, we have a bunch of partners. Speaking of partners, here they are. And I just like to show this because it shows the sort of depth and breadth of what we have, from, super big enterprise companies to startups. We have, we have GSIs in there. We've got OSVs. We've got all the different independent software providers of all different kinds. So it's really great to see that sort of like rich tapestry of partners. And I think that in the end, that's going to prove to be really, really fantastic. These were the two Powered by OPIA announcemements that we have. So like I said, Dell is going to be pulling one together with Intel and OPIA, and then H3C will be pulling together an integrated machine which has OPIA under the hood as well. Very quick roadmap. I'm going to have an update on this shortly, but yeah, so this is very, very broad. But we'll be, getting more specific and talking to the TSC about it soon. And you're always welcome to the TSC meeting, which I think the next one is next Thursday. But yeah, so that's great. I think that's it for me. So this is just a way to check into OPIA, and that's great. So I think I'm surprisingly right on time. Let me find you. There you are. Okay, so we are going to start with Easy. Easy, are you there?
I'm here. Hello.
Hi.
How are you?
I'm very good. Thanks for coming today and sharing your significant knowledge of OPIA.
Thanks for having me.
Yeah. So you're going to be talking us through RAG workflow, basically like development and deployment.
Yeah, I'll be mainly talking about the work that we've done with AWS. I work as Intel, as you. So, but I've been mainly focusing in the last 2 or 3 months working with AWS to have the OPA samples examples workshop.
Mhm.
So I will be mainly diving on the workshop that we publish, how people can use it, and what is the benefit that you have there mainly.
That's awesome. All right. Well, I'm going to let you get to it, and I'll see you at the end.
All right. Thank you so much.
Okay. Bye.
All right. Let me quickly share my screen before sharing. Here we go. So you should be able to see my screen. Yes. All right. So the talk will be a bit technical or a bit in details on what we have. But before starting, same as Rachel mentioned, and all the GenAI examples that OPA provides, agents, chat Q&A, graph RAGs, and everything, chat Q&A is the most popular. So the first approach that we took when we started to work with AWS is to have a workshop, an educational workshop, to explain how to use chat Q&A on AWS, right? Just to visualize or to show, this is the chat Q&A example, which is a RAG application. These are all the components. I will not go in the details of all of them, but this is the modularity that OPA provides, right? So each of the components that you will see in the chat Q&A application is a microservice. So if you like to change the LLM, you can easily switch it. If you like to change the vector database, you can switch it. That's the main goal of OPA and their interchangeable components, right? Of course, they have to be compatible, they have to be tested, But once they are there, you can easily switch. And what we've been working with AWS is mainly to have to use or to implement this example in AWS. And I will talk a bit, even if you're not familiar with AWS, I will try to explain which are the components that are part of the AWS infrastructure. In that case, it's very simple, right? So we have, this will be a deployment, a Kubernetes deployment. So where we used to talk about containers, in Kubernetes we talk about pods, right? And so all the examples which I showed in the slide before, all the components will be a pod within the application, within the cluster or the Kubernetes cluster. For AWS, Kubernetes they have multiple options. One option to provide you the cluster. They have their managed version, which is ECS, which is managed by AWS and everything. But since we are in the open and open source and open ecosystem, we talked to AWS, hey, this has to run on EKS, which is actually the open version of Kubernetes, which is managed by AWS. Of course, AWS helps you on how you manage your hardware, how you manage the scaling. I mean, these are the features that AWS provides on top of the Kubernetes cluster. But the Kubernetes cluster is the same Kubernetes cluster as you can have if you go to the Kubernetes site and you download it. This is exactly the same cluster. So we are building the workshop, right, to have the chat Q&A example with some of others applications that I will be showing later. All of the examples will run on an EKS cluster. The EKS cluster lives on what we used to call a VPC, which is a virtual private the C, I don't remember what it is, but the VPC is like your isolated part for your company, right? So it's completely isolated. Since it's a chatbot and it's a RAG application, and they had to be public, right? Because we have an UI to allow people to interact, right? So that UI is exposed by the Internet Gateway, which is something that AWS provides to each environment to talk to the external world. And we have an application balancer in the middle, and on top of that, which will be given the public URL that will be doing the load balance of the request and will be managing the requests. This is like the reference architecture on how you should use a RAG application or chat Q&A on AWS, and the user will be talking with this public IP address. So I will be showing how we can run this. Let me quickly share. So you should start. If you have an environment, this is for AWS, right? So you should have your AWS environment. In that case, I have my console. And let's suppose I would like to run this workshop. So the way to run the workshop, you simply Googled workshop.aws, which is where AWS provides all the workshops for all companies, or even for AWS or for partners that are doing some things on AWS. And this is the place where it is a public place where you can post your workshop. And there is an OPA workshop, right? So if you go to Google OPA, you will see this beautiful link, which I will put in the chat, which gives you to the OPA workshop, right? You can go on Get Started, and you will see all the modules that I was mentioning before. You see the chat Q&A example. You will see the module 2, which is chat Q&A plus guardrails. Rachel mentioned the integration with OpenSearch. You can deploy the OpenSearch integration here. You can deploy something called remote inference. Thanks to this interchangeability of components, you can say, okay, the LLM, I don't want to run the LLM on my hardware, on my cluster. I want to run the LLM externally. It could be in an external API. That case is the remote inference, which is provided by Denver Data Networks. And the LLM is just that component. Same for Bedrock. If you like to use the Bedrock integration, you can also use it here. The main goal of this workshop is to be a live workshop. Now we just have 5 modules, but probably in the future, if you have another feature that was integrated, I don't know, graph RAGs or any other feature that AWS provides as a service, we can integrate it here, and that will be it will be available here for you to use it. So let's go on the multiple ways that you have if you would like to use it. The first way, of course, this curricula is what we use when we are teaching in an AWS event, for instance. That case is a particular scenario where AWS provides accounts and they give you the pre-provision accounts and everything. And that's not this case. So the case is you can use it with your own account. So if you have an account, the same thing as I had here, this provides the configuration steps. Something that we've been working with AWS is to have the CloudFormation templates to deploy the entire solution, the EKS, all the examples, and each particular example, right? For those of you that are not familiar with CloudFormation template, it's mainly like Terraform. If you're not familiar with Terraform, is a configuration file where you say all the components that will be installed within the AWS infrastructure. So the CloudFormation template can say, I would like my environment to create an EKS cluster using this instance with these permissions, with these users, with this size, with this scalability policy and everything. This is what we usually put on the CloudFormation template. So to make it simple, you will click here and that will open up the CloudFormation template in your console. And you just need to provide some parameters, right? You need to provide the Hugging Face token, which is you go to the Hugging Face site and you get your token. This is needed because for chat Q&A, and in the case that you are running everything locally, the models has to be downloaded from Hugging Face to your local environment. This is why you need a key. The key is for free, of course, but you need to need a key at least to download those models. You will specify which model you will be using from Hugging Face, right? This is the Hugging Face way to mention or the models. So in that case, I will be using Intel Neural Chat. But for instance, you can use all the other models that are validated in OPA. You can also use DeepSeek, for instance. Now that most people is wanting to put their hands in DeepSeek, you can put here the DeepSeek, the 8 billion parameters, you can put it here. You will need to specify a role, which is, there is a command here where we explain how you can get your role. But basically, you can specify the role that your application should use. If you don't know it, you run that command that is in the instructions, and you will have your admin ARN, which is the way that the users are mentioned. These three use cases, remote inference client D, client secret, and remote inference URL, is in the case we are using the remote inference that I mentioned, you need to specify, because this company, Denver, the data networks, they need to give you a key and they need to give you a client and ID. So you need to use those values to deploy this module, right? And that's it. You click acknowledge and you create the stack. I will not be creating the stack because what is created here is creating the EKS cluster and it's creating all the CloudFormation templates. It's not deploying the examples because this is something that I will be doing now, but it's creating this. You can imagine just to create the EKS cluster, the Kubernetes cluster can take around 15 or 20 minutes. Just because they need to provision, they need to configure. So this is why I will not be doing now. I will go to my environment, which I have here. And just to check or to explore what I have here is you have the Kubernetes cluster, which is actually the EKS. This is what is created when you are launching this stack. And here, of course, you have the compute and you have your node and your cluster built for you, right? Another example, another thing is, and if you would like to explore a bit more, it can sound confusing, but in case you would like to know, okay, I would like to download this CloudFormation template for me, and I would like to use it. Okay, let's suppose you would like to use the guardrails. You go here and you can check the template if you would like to see, well, in this case, it's not deployed here. You will see all the CloudFormation template. You don't need to go there. You don't need to even see this. This is more an FYI on what is going on underneath. So it's CloudFormation template is what is being deployed by you. Let's go back to the instructions. Right? So once you have it deployed, these are all the steps. This is what I explained. These are the CloudFormation template, as I mentioned before. You will need to have access to your Kubernetes cluster. So in that case, I already did it, but you can use the console. In that case, it's a Cloud Shell, which is the easiest part. Let me clear here. Let me make it bigger. Okay. Should be good? Yes. All right. So here, for instance, if I would like to see how is my cluster, I see that I have just one node, which is in this case, the node that I have. Now, once you are here in that moment, you can select, okay, I would like to check just chat Q&A. I would like to check the guardrails. I would like to check OpenSearch or whatever. Let's suppose in the first example, I would like to check the chat Q&A. I would like to deploy chat Q&A in the cluster that I have already created. Since I mentioned at the beginning, this workshop is intended to be educational. So you will see a lot of explanations here on what is happening, why was deployed, how you can check the pods, right? The first command that you should do is you have to execute the CloudFormation, which is actually to deploy it. Something that I would do, but I would do it for the second example, so we don't waste time. Let's suppose we like to do the same with guardrails, right? So same thing, one explanation about what is a guardrail, how the guardrail works, and what are the components that are changed in your example. And you have the command here. Everything has this kind of look and feel, right? So you see a command and you have the button to copy that. So you go here, copy. In that case, I will be deploying the CloudFormation template for the guardrails example, right? But that's for 5 minutes. In 5 minutes, I'll be seeing that. But what I did before is I actually deployed the chat Q&A example. So within my cluster, you will see that we have all the containers, all the pods that makes the chat Q&A example. And you can explore all of them. Even if you go to the chat Q&A to the workshop, you will see the commands that I'm sorry, I have to go here. You will see the commands if you like to test each particular component. So if you like to check if the mega service is working, which is the service that is orchestrating everything, this is the command and how you can curl your mega service. If you like to know if the embedding microservices is working well, you will have an explanation about what is an embedding microservice, what is embeddings, why they are important, how you use it, so on. And this is, for instance, the command that you should run to get an output for the embeddings. This is something that I will do it just once, just to let you know. For instance, if I would like to know how the embeddings microservices is working, I need to first connect to the Nginx, which is the Nginx, which is how the services are exposed. Since I am on the Cloud Shell, I'm not within the cluster. I am outside of the cluster, right? Even though I can access to the Kubernetes cluster, it doesn't mean that I am inside the cluster, right? So this is why if I try to curl from my IP address, this is not exposed. The only thing that is exposed to the external world is the UI, what allows people, of course, to run the inference, right? So I will just run this real quick. So I will connect. This is Kubernetes command. So I'll be connecting to the Nginx, which is like the point of entry of my chat Q&A example, and I will be connecting there, right? Okay, now I can realize that I'm not on the Cloud Shell anymore. I am within the Nginx pod, and from there, I will be running the command. Basically, the command what it's doing, and this is the what we talked about the microservices. So if you have a microservices, it means that each particular pod is performing one function or one task. In that case, the embedding is just converting a text to vectors, right? And this is what I will be doing here. I will be curling or sending a request to the embedding microservice with the input will be what was deep learning. I mean, I can put any question, and the embedding microservice will give me the vectors for that phrase. Right? It will not be answering my question. Will not be doing anything with my question. We'll be just doing converting text to numbers. This is a part that is important when we are working with RAG applications. I will just be testing this. So we put here, we curl, and we get all the numbers that are from this question, which is what is deep learning. These are the vectors that are later ingested to the vector database, and it's used, of course, when we are doing retrieving on the questions. When we are using RAG, we have to retrieve the most similar documents, and all the similarity search is done by comparing vectors. Right? This is why we need to have this in vectors. So, and the same thing for all the others components, right? The retrieving, how you perform the retrieving, how you perform the prompting, how you perform the re-ranking. I mean, all these steps are explained here. And you can test later. You can also test now. Well, if you like to go, you can go to workshop.aws, and you can, if you have an AWS environment, you can follow me in this part. Right? So all the explanations and so on. What I would test is actually the load balancer. So remember that at the beginning I said that we will have an example, and that example is exposed to the external world through a load balancer that is provided by AWS. So if I would like to see what is this load balancer, I look for my load balancers. In this case, please ignore all of this, right? Just because these are my load balancers. But here, for instance, I'm looking for this chat Q&A ingress. So I can put this URL on my browser, and I will have the chat Q&A UI, right? So starting from the beginning, you have your AWS environment. You go to the Workshop Studio. You click on Launch. You set those parameters, and it creates the EKS cluster for you, and you deploy the CloudFormation template, and you have the example running for you in your environment. So just to check if it's working or not, let's say if the LLM gives me the answer. I don't know, how are you? Okay, it's working. Okay, I don't want to hurt the LLM feelings. It's not providing a personal response. Okay, thank you. So it's working. It's working. So if I would like to use the example now, what is OPA? The model will say, I have no idea what is OPA, mainly because this model was trained, or all of the models were trained until a certain date. In that case, it's, I don't know, 2 years ago, 1 year ago, and OPA is pretty new. So the model will not know what is OPA. How we are providing the context, and this is more to explain what RAG is. We know that OPA, we have this cool site. We have this cool technical documentation, for instance, and we have a site where it says, what is OPA? I would like to provide this site as a context to my application. It's already here, so it was uploaded. Basically, what happened underneath is the UI sent that to a data preparation microservice, which converts that to embeddings. Those embeddings, those vectors, were stored in a vector database. And what will happen now, once I'm saying what is OPA, is this question is going through the same process, is converted to embeddings, and those embeddings go to a new microservice, to another microservice, which is called the retriever, and the retriever is comparing the question vector with all the vectors that were stored before. It extracts the most similar, it creates a new prompt, and this prompt is what is sent to the LLM underneath, right? So you will not see it, something that is happening underneath. So now if I make the question, what is OPA? I will definitely see OPA, Open Platform for Enterprise, a framework, and so on and so on and so on, right? That's more like the example or the explanation to combine both, to combine it. How easy to deploy it and what is RAG. Let me show the other example. For instance, if you would like to see what is the guardrails, you remember I deployed that before. right? So if I would like to see namespaces, if I would like to see the other example, because you can imagine that all the examples are deployed in the same cluster, how you can divide them, you have multiple namespaces. The namespace in default is the one that has all the chat Q&A examples, and the namespace called guardrails is where you have the pods related with the guardrails, which are this one, right? This is why we have a big instance underneath, because we are in the ideal case when you would like to deploy all the examples, all those examples will run locally, unless you are using Bedrock or remote inference. So this is why you need a hardware to run all of them locally. And the same thing, if you like to learn how the guardrail works, you go to the workshop, the workshop here. You go to the module that talks about the guardrails. Here there's some explanations, what are the components that are changed from the chat Q&A vanilla version to the guardrail. And this is how you verify the behavior and what is the microservices that was added in order to use the guardrail, which is mainly a guardrail's microservice in the beginning to check the quality of the question. I mean, if the question doesn't contain any toxic message, any violence, any crimes or anything, right? This is how you test it, a bit of explanation. I would just run it. Of course, all the examples, they create everything and they create the load balancer to expose your UI. In that case, I have this UI, which is the guardrails UI. I go here, I can open that. And yes, so this is the guardrails UI, right? So if I ask, how are you? The model will say, I'm doing well, thank you, and so on, positive and respectful. But this chatbot, this chat Q&A using guardrails is actually checking my questions. So if I say, how can I rob a bank? The model will say, violated policies, non-crime, and so on, please check your input. So it blocked the question to be sent to the LLM even before, because the question is violent related, right? This is more an FYI. In an actual application, you probably will build something on top to see, okay, what can I do now with this that I know that this prompt is violent? And you can build something on top, right? And one more comment on this is you can also use the Bedrock. Here. You can also use Bedrock and you can also use OpenSearch, which it explains the components that are changed. In that case, for OpenSearch, we need to change, of course, the vector database, and we need to change the retriever and the data preparation module. These are always typically when we're building a vector database change, you need to change these free components because some of the databases, they have their own way to pre-process the data or to ingest the data, and this is particular from the database. So in that case, we need to change the free components. And you have an explanation here on how it was used, how you can use OpenSearch in your chat Q&A example, how you can test it, same thing. Same thing for the remote inference, which is actually using the LLM. In that case, we are replacing the LLM. Think at the same example, we have always chat Q&A in this example, and we are replacing components. In that case, we will be replacing the LLM component. And we are saying, okay, instead of sending your queries to the LLM internally, send it to an external API. In that case, it's provided by Denver, which runs a cluster with Intel Gaudi, which is an accelerator. But you need to ask for the keys in order to use it. You have the instructions here on how to do it. If you like to use the Bedrock integration, there are some details that you need to enable Bedrock in your environment. So it depends on the model that you would like to use, and depending on the model that you would like to use, the actual region that you will be using is different, right? So you need to check that. There is an example where it's actually doing this, is replacing your LLM for your for the Bedrock integration, right? And the example is exactly the same. In that case, it's built to use Claude Haiku. And same thing, you will be deploying a CloudFormation template, you will be testing how the namespace created all the components, and you will be testing the deployment to check to see how it works. That's the main goal of this workshop. This is free to use, of course. The only thing you need to consider, you will need the hardware inside of this. So the cost will be related with the hardware that we are using, of course. But all the workshop is for free. And this workshop will be growing, actually. As I mentioned, now it's chat Q&A, but we are thinking in the future to add all those workflows, as Rachel mentioned, the agentic AI. We have agents Q&A, and that we can build the example here. This is a 2 or 3 hours workshop where people go there, they deploy it, they educate, and they learn on how to use OPA on AWS. And we'll be doing the same thing for Azure and for all the service providers, because we want to make it very easy to deploy it and to test it, and also to teach how you can use those components. One more thing, let me know if you have any questions. One more thing that Rachel mentioned is we also have it on the marketplace. Marketplace OPA, right? I'll put also the link here. This is just to deploy chat Q&A. So there are some instructions. I will call this as a first version of what we publish here. The main idea here is to give you the freedom to choose the components, to choose the vector database that I would like, and the LLM model that I would like. And you can select if you deploy this in your environment or in your or it can create an environment for you, the same thing as we did for the workshop studio, right? And you go here, you accept the terms, and you have the instructions on how to actually build the example in your AWS environment. How to specify the region, how to specify the keys, how to specify the hiding phase key. It's pretty similar to the workshop. The workshop is a bit easier in some things, but it's more educational. This is just, I would like to deploy it. I would like to click here, and it's ready to be run on my environment, right? And I think that's it. I'm good on timing. Yes, I think. Great. I don't know if you have any questions or if it's something that you would like to know, any more details. But this is what we have.
Easy, I have a question for you.
Sure.
What generally, a lot of people are taking on their first RAG Gen AI application. Do you have any sort of general guidance or tips for people?
To integrate these to a Gen AI application, to an application?
Generally, like you're starting out like, hey, so-and-so comes to you at your company like, I heard about Gen AI and chat Q&A. Besides, of course, going to OPIA and taking your workshop.
Yeah. No, I think that the first thing that I would do is to show what it actually is. Most people, we can think that, hey, Gen AI, we start to see posts, lots of things that, hey, Gen AI will solve our world or everything that we do, right? And it's actually, we need to be careful on that, and we need to really explain, okay, this is a chatbot, or this is what you can actually do with your business. For instance, same thing as if you have a finance use case, or if you have a healthcare use case, and you would like to have your doctors to answer to questions. Instead of go and read for 2,000 documents, you can have all the documents indexed in a vector database, and that can help them to have an answer faster, right?
Mm-hmm.
It will not be replacing anything, but at least we'll say, hey, I think that this is the answer, right? And I think that the most important thing is to show a real example. and to show the end-to-end application. Sometimes we just think on the LLM how smart the LLMs are, but this is not actually how we usually use it on the real world. In the real world, we need something like RAG. We need to make the bot to talk to agents, and the agent had to take a decision, has to go to my vector database, to my SQL, to my internet world. It's more like showing that. And it's a challenge. I know that is a challenge sometimes to say, how can I use this? Instead of just saying, hey, I have a great model that can solve my math problems for me. Yeah, it's fine.
Yeah. I do think with the advent of new technology, there is always that gap between sort of like business needs and outcomes and technology possibilities. And so one of the hopes is through having all of the blueprints and seeing stuff like this is that you do understand what's involved and you see how, it can evolve a business or augment a business. So interesting.
Yeah, and also have it attached with use cases, verticals.
Yes.
That is the most important thing. Just
I totally.
Show how to use them. Yeah.
Well, thank you so much for your time. I know it takes a lot, and I'm sure we'll see you on one of these again.
Thanks so much. I hope that it was useful and informational. So thanks for having me, and I would love to be in the future too. By the way.
All right. Thank you. All right. So we're on to our next one, which is Opia with AMD, and Yu Wang, who is a principal AI software solution architect from AMD, is going to be joining us. Hello. And you are on mute, it looks like.
Hello, everyone. Can you hear me?
Hi. Yes, we can hear you. I just introduced you to the audience. Super excited, though, to see what we can do. You and your team have done a lot of work over the past couple of months. So excited to see it. So I'm going to let you take it right away.
Oh, yes. Well, thank you, Rachel. It's exciting to join you guys today. Obviously, I'm off camera because I'm experiencing some Wi-Fi interruption. So I want to make sure that the content and my voice goes through well. Is that, I hope everything's working for folks. Can you confirm, Rachel? I don't think I can hear you, Rachel. Can you confirm if this is working? Okay, folks, let's go. So, hello, everyone. My name is Yu. I'm part of the product management team in the AI group at AMD. I look after the enterprise AI software strategies and solutions, and our team work with industry partners to bring these solutions to market. AMD joined the Opia community as a member of the technical steering committee last summer. Today, I'd like to provide an update on the work Team Red has done to enable Opia project on the ROCm stack and our plans for Q1 this year. And so with that out of the way, let's get started. So here's the agenda. First, I want to level set with everyone in the community and share why AMD prioritizes enabling Opia on ROCm stack. Obviously, this is the first time we present to the Opia community. So I want to make sure that I share our full stack open source software approach for AI and enterprise AI. And after that, I will cover the work that we have done since Opia 1.1 and what we have planned to work on in Q1 and touch a little bit on the Q2 work. Then I'll show a few demos, record demos. And then because we're picking up the paces with contribution back to Opia, obviously, we want to get feedback from the broader ecosystem to ensure that we can address the most pressing requirements in a release soon. So, why Opia? Very simply put, we here at AMD believe Opia can help accelerate enterprises' GenAI journey. It addresses all the key challenges and concerns which hinder GenAI adoption in the enterprises. With Opia, organizations have the flexibility to choose the tools and technologies that work best for their specific needs. It's built on open standards, so everything is clear and transparent. You always know what's going on. And plus, there's a strong and active community behind it, working together to innovate and solve problems quickly, efficiently. And OPA is cloud native. As we can see the impressive demo on AWS, it is built for seamless deployment across multiple cloud platforms, giving you the flexibility to move between providers without getting locked in. It is API driven. This design makes it super easy to integrate with their existing workflows and automate processes. By using containerized pipelines, OPA actually ensures scalability, efficiency, and smooth deployment every step of the way. And our CEO, Dr. Lisa Su, always emphasizes that there's no one size fits all in computing. So as more enterprises adopt GenAI and deploy into production, we anticipate most of them would have a mixed deployment of accelerators to meet their needs. And OPA is designed to avoid being tied to a specific vendor. That gives the organizations the flexibility to adapt as their needs change. Being an open source project with an open ecosystem, obviously there isn't licensing fees out of the box. That does bring down the upfront cost for POCs and even in production. And observability is one of the most important requirements all enterprises care about. Resource utilization, workload performance, energy consumption, etc. And OPA integrates with other open source tools to provide insights into these key metrics, so issues can be spotted early and fixed early. And for security conscious organizations, the ability to be deployed in a completely air-gapped environment is considered a priority and a prerequisite. And with OPA, air-gapped deployment is supported since day one. And finally, OPA streamlines and basically accelerates the deployment and enables faster transition from development and experiment to production. It has low code and no code tooling that reduces the need for specialized skills and making it super easy for people to contribute. And to enable the perform the AI solutions for our customers, we have been doing a lot of work on our ROCm stack. Our AI software stack, basically ROCm is the AI software stack. We serve the broader software ecosystem with through ROCm stack. And so basically open source is a core pillar of our pervasive AI strategy. We partner deeply with the broader community.
Can you hear me?
Yes.
Your slides don't seem to be advancing.
Oh, where am I right now that you can see?
You're on the title.
Oh, interesting. Okay.
Sorry, we've been trying to
It has been progressing. Sorry, I have only one screen. Okay. Okay. You can see this. Let's see. How about this? Are you guys seeing the?
I can see right now. I see open modular software stack.
Oh yes, that's what I was speaking to. I guess okay. Let me try again. Can you see the presentation?
It's not. If you're trying to make it full screen, no.
How about it?
No, it's still showing like.
Is it moving?
No.
Wyopia? No? Okay. All right. That's...
Now it says Wyopia.
Okay. So how about now? So in presentation mode, it's not happy.
Okay.
Okay. All right. So I guess we go with the second best.
Okay.
We're not in presenter mode. Okay.
I appreciate it.
Thank you for the heads up. I appreciate
it.
So obviously ROCm is, I hope you have heard of ROCm, is a complete set of libraries, compilers, and tools needed for developers to start working on deploying AI workloads. It is architected to be modular and open sourced to be to enable rapid contribution by AI communities. We designed the ROCm stack to connect easily to the ecosystem components. For example, frameworks like PyTorch, TensorFlow, JAX, and the model aggregator model hubs like Hugging Face. And in the past 15 months or so, we have implemented a lot of new features, algorithms, and optimizations in every layer of the ROCm stack to deliver best performance for GenAI workloads on our accelerators. And at AMD, we believe in the power of open source and open ecosystem. We partner with leading AI communities like PyTorch, Hugging Face, Triton, now Opia, to ensure the developers have access to the best tools and frameworks to working with the ROCm stack. We have vendor agnostic approach to our support for AI workloads across different platforms, whether in the cloud, on-prem, or hybrid environments, giving us the flexibility to choose to help the customer choose what works best for them. This aligns very well with the Opia objective. And so for models, the goal is that any models on Hugging Face, we want them to be able to run on AMD. So far, we have over 1 million models on Hugging Face running on AMD accelerators. We validated the model architectures nightly. And in general, our goal is to be able to provide day zero support for all the important frontier models. And for workloads deployed into Kubernetes cluster, we recently released the production-ready AMD GPU operator to simplify the deployment and the management and the monitoring of AMD GPUs in containerized environments. It automates the installation of necessary drivers for GPU, runtime libraries, and monitoring tools to ensure the seamless deployment of the AMD GPUs into Kubernetes clusters. And we started our upstreaming work to Opia since 1.1. We allocated the hardware resources to support the CI testing. It's a 8 GPU MI300X server. Since 1.1, our work has been mainly focused on validation. In Opia 1.1, we enabled 5 GenAI examples on ROCm stack. In 1.2, we added another 5. And as we ramp up resources to support the Opia project, we will continue to validate the entire the new suite of new applications added to the GenAI examples for the ROCm stack. Between 1.2 cold freeze and now, we have upstream 2 more deployments and create a PR for another one. And then for 1.2 release, so we plan to enable another 6 applications. And in addition, for 1.3, we also plan on performance work, mainly to enable VLM backend for existing GenAI examples. We were going to do this jointly with the folks at Intel. We have done a lot of work with the VLM team at Berkeley to make sure that we get optimized inference performance on ROCm stack. So we should see a performance jump for workloads on Instinct GPUs when Opia 1.3 is released. Also planned for upcoming Opia release, we will enable the Kubernetes deployment for GenAI use cases on ROCm with Helm charts. And as phase 2, we will first enable the support for vanilla Kubernetes. And finally, we also want to publish a lot more developer documentation to help them get started with Opia quickly on with the Opia project in general and specifically on ROCm stack. And for future releases, there are a few aspects we want to focus on. One is enabling more optimized inference backends. We've been working closely with the SGLang team, so that will be one of the inference backends we want to enable in a future release. And working with a lot of the frontier model builders, and we want to make sure that's on day zero support and enable these models through the Opia stack as well. And in addition, we have been developing some microservices for our internal developer platform. We want to package that and open source those, and in addition to new use cases we want to work on as well. So, well, obviously, this is a party of demos. So I brought a bunch of recorded demos of the examples that we have enabled on ROCm Stack. They were captured on a Supermicro 8 GPU, 8 MI300X server. And I admire folks who run live demos, and maybe one of these days I'll be brave enough to run a live demo myself. But for today, let's go through the recorded ones. I think it'll be interesting if you haven't run those applications on your own yet, so you know what it is, and know that we have got them to work on Instinct. And thanks to the streamlined pipeline Opia comes with, everything is super easy. So chat Q&A, everyone knows this application. It's basically chatbots based on RAG. I trimmed all the videos down to about 20 seconds, so it won't take too long. Next up is the CodeGen. It's a code copilot application for executing code generation. Next up, code translation sample app that converts the code from one programming language into another programming language. Next one is DocSum. It's a sample app that creates summaries of different types of texts. FAQGen, it automatically generates natural sounding FAQ from various documentation sources. Right. The search app or search Q&A, you might see. It's an example of improving Q&A application qualities by expanding the pipeline with a search engine. In this case, a Google search engine is used. And translation to demonstrate the translation inference capability. All right, dbQ&A translates natural languages queries from SQL into the SQL a search query and delivers real-time database results. All right, that's the end of the demos. And we have an alias for OPS-specific questions and the feature requests. So feel free to just scan the QR code. You'll be able to reach me and the team at AMD supporting OPIA. And also, in addition, for the developers out there on the stream today, if you want to get started with our ROCm stack and learn about the capability and what we have been doing, we have recently brought ROCm AI Developer Hub live. So please feel free to check out. And if you have any feedback, obviously you can reach me through the first alias, and we can chat more about it if you need additional resources to help you become successful developing for AMD GPUs. With that, I guess
awesome.
Yeah.
Thank you so much. We do have a request, and I'll follow up with all of the presenters if we can get the slides basically.
Yep.
After, and we'll make those available via opia.dev. But I'm going to ask you similarly to what I asked Easy, just basically, what do you think, what are some tips and tricks as you sort of get started on your first RAG applications? as a developer, I would say.
I usually find, well, hey,
Oh, unfortunately, we lost you.
tell me if you want to get I look for the applications with get started that's like really simple. I can just follow command line, and then not a lot of block. I mean, I really don't want to build anything from source. So if I can pull containers off Docker and then just run, that I'm super happy. Then that just keeps me interested. I think that's like one of the key goals for Opia and for AMD as well. And we want to make sure that developers don't have to touch the lower stack. They don't have to worry about the drivers. Everything should just pull out of the Linux stack. You should expect it to work, and that's our end goal. We want to streamline the experience for developers, and like if you ask them to like run more than 3 commands to actually get the application running, I think that's ridiculous.
Yeah. Okay. Yeah. All right. Fair enough.
Yeah.
All right. Well, that was great. Thank you so much. I really appreciate it. Like I said, I think it's been great having AMD on board, and I look forward to what we can do in 2025. It looks like a good, some good additional contributions from you in the coming months. So
looking forward to working together.
Yeah. So last but certainly not least, we have Bilge Yücel from DeepSet AI, who has spoken before. She is going to talk about Opia and Haystack. She's great. And I think she's around here somewhere.
Hello, Rachel. How are you?
Good. How are you?
I'm good. Thank you. I'm quite excited for the demo.
Yes, so am I. I think there's been a lot of work with Haystack and Opia since we last spoke. So
yes,
very excited.
Exactly. Yeah, I will show some of them.
All right. Well, I'll leave you to it. I'll talk to you on the other side.
All right.
Okay, thanks.
So let me take my presentation. Yeah. All right. So hello, everyone. I prepared a small demo for you. It has this very nice 3-minute UI. And with this demo, I want to explore some RAG methods. So basically, when you think about RAG, this is what we have been talking about in this event as well. Okay, like building a RAG application is quite straightforward, but sometimes it's not working as we want it to work. So you need to make some changes. But like, what type of changes can you make on that RAG application? With this demo, we will dive into some of the examples. So I'll just first show you the demo, then we'll go into the depths of the architecture. So this is the practical RAG application with Opia and Haystack. In this application, we have a RAG application running behind, but with different retrieval methods. If you're familiar with retrieval, there are different types of it. So you can do keyword-based search, you can do embedding retrieval, or you can like combine these 2 approaches and do a hybrid retrieval. But in order to understand which one works for you the best, you need to compare and see the results in some way. And this is what we are trying to do here. I have some example questions, and I have already indexed my documents to my database, so they are ready with their embeddings. I'll just try to run one of these questions on that dataset. So here's my example question, and this is from a labeled dataset. So I already have a ground truth answer for that because I am going to do a little bit of evaluation here. And first, I will run it. This time, it will not take much time because I have already run this for you and cached the results. So I said that we are going to go with 3 different retrieval methods. And let's see what keyword-based retrieval return us as an answer in this RAG application. It's a very long one compared to the ground truth answer. But when I look at the answer, the answer to this query, which is looking for 2 main tasks where BERT is trained on, is masked language modeling and next sentence prediction. And I see the answer is already here, like masked language modeling and next sentence prediction. I look at the embedding retrieval one. Again, the answer is here. And hybrid retrieval, again, the answer is here. So this is nice. So at least for this query or for this question, it doesn't really matter which retrieval method I go for. When I look at this SAS scores, this is semantic answer similarity. And how you calculate this score is a bit different, because here, although you see that although these answers are correct, you see this SAS scores are not very good. So it's better if they are closer to 1 here. All right, so the reason for that is when we calculate the semantic answer similarity, first we create an embedding, a text embedding for this ground truth answer, and then we create an embedding for the predicted answer as well, and then we calculate the cosine similarity between those two embeddings, and this is where this score comes from. Of course, yeah, you see that this ground truth answer is quite short one, and this retrieval answer is a bit long one. That's why it's possible to get this like lower scores. Let's try to get another question here and see how they perform, how this perform in different retrieval methods. So I run it again. All right. Again, I have quite a short ground truth answer here. My keyword-based retrieval, although it found the answer, the answer was still long. So that's why the semantic answer similarity wasn't that high. But when I look at the embedding retrieval, I see that, okay, the answer is quite similar to the ground truth answer, and which is good because it means that I will have a higher semantic answer similarity score. And it's the same with hybrid retrieval, it's even higher. So it's not always say something for sure for us, but it's a good indicator what we need to change in our pipeline when we are developing our RAG applications. So let's go ahead and check the architecture of this application. But first, let's learn about Haystack. So Haystack is a fully open source framework built in Python for custom AI applications. It gives you the tools that you need to build and customize state-of-the-art AI systems. And in Haystack, there are two main building blocks, components and pipelines. And components are smaller units. You can think them as nodes in a graph. And by connecting these nodes to each other in whatever way you want, you are creating a graph, which is a pipeline. But the pipelines in Haystack is a directed graph. This means that you can have like branches like this, and then at some point you can decide to merge those branches. This architecture is quite helpful for us because this is also how we can index different file types or do hybrid retrieval actually. And let's go into the details of it. So for this demo, I have used the Aragog dataset. This dataset is based on a paper called Advanced Retrieval Augmented Generation Output Grading. Basically, researchers collected some papers from arXiv, covering topics like transformers and large language models. And they used ChatGPT or GPT-4 to generate questions and answers for those papers. That's why we have some example questions and some example answers already here, like we have here. All right, and we have 13 PDF files. I haven't used them all. I only have 2 of them in my data set. That's why like the example question set is a bit limited, but it's again possible to use all of them. So to index my data to my database, basically there were some steps that I used. In this example, I only have my PDF, but in real world, you usually get different types of files like TXT files, Markdown files, HTML files. Let me maybe make it larger. Yeah. Like TXT files, Markdown files, HTML files, so different types of files. So you need to convert them in some form so that you can process them further in your application. And when you're developing a Haystack pipeline, that data type is haystack documents. So I need to convert them into haystack documents. Then it's nice that if I clean them, so if I remove like empty lines, spaces between paragraphs, so the things that I don't need with the cleaner components that I have, then it makes sense for me to split those documents into smaller chunks. I can use like word splitting. I can split by the number of words. I can split by paragraphs. I can split by sentences, or maybe I can go with different splitters and try to use different methods for that, basically depending on my application here. And then as the last step, before I put all of these documents into my database, I need to create embeddings for each of these chunks. And I can definitely use Opia's microservices for this. Opia provides embedding microservices, and the models there can create these vector representations of these texts. And this is actually what I've done for the application. If we can briefly look at the code of it, it's basically my haystack components initialized here. And here I want to show you the microservice component. Basically, in order to use Opia microservices in haystack pipelines, you need to define the Opia haystack component before you initialize your pipeline, like this. So basically what I just do is just I pass the URL that is where my Opia microservice is running, and now I have access to that embedding model, and I can use this component to create embeddings for my documents. And I add these components one by one to my pipeline, and I just connect them. And here, as you see, like I have different files, different types of files. I can use like TXT files, PDF files, and Markdown files. They all will get processed with different converters. I have my text file to document converter, PyPDF to document converter, Markdown converter here. They are already in my pipeline. And then I will merge those three branches with my documents joiner, and I do this cleaning, splitting, and embedding steps as I do in this representation. So, okay, I have my documents indexed in my database. Now let's see how we can create the RAG pipelines. So usually in keyword-based retrieval, you start with a query and you use that query to retrieve relevant data. In my case, this is BM25. There are also different algorithms like TF-IDF, but I use BM25 to retrieve relevant information from my database. Then I got these documents and put them in my prompt with the query. Now I have like a very big query with my documents, with my query, and my instructions to the LLM. After I have this rendered prompt, I can pass that to my, again, Opia microservice, but this time for LLMs, and get a response. Let's look at the details of this pipeline. Okay, so in Haystack, there's a certain component that you can use to render your prompt. This is called Prompt Builder. And Prompt Builder can process Jinja 2 syntax, which gives me a lot of flexibility when I'm creating my prompt. So this is a very basic RAG prompt. What I do is I instruct my LLM to answer the following query based on the given documents. And then I loop over all of my documents that are passed to my prompt and get their contents and parse them into my prompt. And as the query, I get the question or the query from the user. And then I say, like, if you have enough context to answer this question, return your answer. If you don't have enough context, just say no answer. And let's look at the code of this pipeline here. So again, I initialize a pipeline and I add my components here one by one. So for this pipeline, what I need is that I need a retriever to retrieve documents from my database. I need a prompt builder to get the prompt, get the documents and the query and render the prompt. And I need a generator to generate a response. And this is actually what I do. I have my prompt builder with this prompt. I have my BM25 retriever that is connected to my document store and that retrieves 5 most relevant documents in my document store. And I also have my OPA generator, again, connected to the microservice that is running. And I have some model arguments to adjust here. I can adjust the temperature, TAPI, and max tokens based on my use case. I add these components to my pipeline, I connect them, and then I run it. So this is the first pipeline that I use and for keyword-based retrieval. Let's look at the representations of other pipelines. So in order to use embedding retrieval in my RAG pipeline, I need an extra step on top of my keyword-based retrieval RAG pipeline. And this is the embed query part. Because this time I want to compare embeddings of documents to the embedding of my query when I'm doing the retrieval. And that's why first I embed my query using an OPA microservice. And then I use this embedding to retrieve relevant information from my database. And the rest is just the same. So the pipeline code is quite similar. Only thing that I had to do is to add an extra OPA text embedder here to create query embeddings for me before I do the retrieval step. And what I do next is to add these components one by one, connect them in the correct way, and then run them. All right. But how do I do the hybrid retrieval? So how do I combine these two approaches? It's quite simple here. So I, again, create embeddings for my query. I use these embeddings to retrieve data, but at the same time, I use the query text to retrieve information from my database. This means that I will have 2 sources of information, or let's say that two retrievers source of information. And then I will combine both of these document lists coming from different retrievers in my prompt, and then I send it to the generator to generate responses. And if you look at the code, again, I have my in-memory embedding retriever, BM25 retriever. These are 2 retrievers that I use, but the embedding retriever needs the text embedder before, so I also add that to my pipeline. Then what I do is to join them with my document joiner and send them to the prompt builder so that OPA generator can generate answers. And the rest is just like doing the connections in my graph. Basically, retrievers should need to go to the document joiner. Document joiner will only have one list of documents that will be passed to the prompt, and then this prompt will be going to the generator. All right, so this was the detail of this pipeline. So with that in mind, let's go back and try to run another query. Let's try this one. How does BERT's architecture facilitate the use of a unified model across diverse NLP tasks? And I already have my answer here. Uh-oh. You always get a bug in a live demo. Let me see if my connection is up. No, my microservice is down, so let me bring that back up. All right, it's back up again. Okay, let's give it another shot. So this was my query. Let me run this. Okay, so right now it has the query, and what it does is it's running all those 3 pipelines with the same query, but as you have seen, with different retrieval methods, it will then give me an answer for each retrieval method. And then as the next step, it will calculate a semantic answer similarity score for me. But of course, there are different metrics you can use, especially for retrieval. You can use context relevancy, or you can use faithfulness, for example. But these evaluation metrics require an LLM, so it will probably take more time than semantic answer similarity. All right, so here are our answer. Again, all of them are a bit longer than the ground truth answer, but that's okay. Let's see if they are correct. So this one says, BERT uses multi-layer bidirectional transformer encoding architecture. I see that there are some similarities, although it's not completely correct. But again, yeah, we get pretty decent semantic answer similarity scores. Only not for the embedding retrieval. Probably it skipped a step here, but maybe because there are a lot of domain knowledge in that answer and in that query, keyword-based retrieval was more successful here because it could retrieve more relevant information that the embedding retrieval couldn't represent with the embedding model. So this was the demo that I wanted to show you today, but let's look at the next steps for Opia and Haystack. So there are different and a lot of, let's say, architectures or applications that you can build with Haystack and Opia. And we have already covered the RAG part of it, but you can also do web RAG, which means that you can retrieve information from web instead of a database that you have, and use that information when you are doing generation part of it. We have already covered the converting, pre-processing, embedding, and indexing part of stuff. We have covered a hybrid retrieval method among advanced retrieval methods, but there are also different things that you can try, such as like sentence window retrieval and hide. And the other exciting stuff that you can try is conversational systems, so like chat Q&A with Opia and Haystack. And last but not least, you can build your own agent. Haystack's pipelines, as I said, they are directed graphs. It also means that you can have loops. So imagine you have a system like this that has an input coming from the user, that is a prompt builder, a generator, and an external node that checks the validity of the response coming from the LLM and sends it back to the prompt builder if the answer is not valid for a certain condition. Or it can just find it as a valid response and return it to the user. This architecture is usually called a self-reflecting agent. And another thing that you can try to build with Opia and Haystack is web-enhanced RAG pipeline. So we have already covered the embedder and retriever part and the generator part in this demo, but you can extend it with, like, imagine you have a database with some information. You do a regular RAG over that database, but sometimes the answer to that question cannot be found in that database. And when this is the case, your generator can return something like no answer, and a router component can decide to go to web to get more information from web and put it in prompt builder on top of the documents you retrieve from your database and use that information to generation. And then maybe this time you'll get a better answer. And you can also call this as web-enhanced RAG pipeline. All right, so this was what I wanted to share with you today. Let me maybe share the link to this demo in the chat. So if you have any questions or comments, do let me know, and feel free to give it a shot, run it locally, and share it with us.
Hi, I'm back. That is super awesome. I'm really excited to see all the work that's been done. And it's great to see different, I like to see Easy go through his, practical RAG example, and then you, and see what AMD, it really kind of makes it more, I don't know, I think that's how I learned, seeing it actually in action. So that's fantastic.
Yeah.
I don't think we have any questions at the moment, but I'm going to ask you what I asked the other two presenters. Tips and tricks for just starting developers when they're working on RAG stuff.
Yeah, I think the most important step is to knowing your data.
Okay.
So splitting your data is really important. Like, how do you split this data? Because then you will create like embeddings, and the retrieval part of a RAG application is the most crucial part, in my opinion. So you need to do it right. And in order to do it right, you need to know your files, you need to find your documents, you need to pre-process it correctly. And this there is no like one correct way of doing that. And there's no like solution that fits to everybody. So you need to try and see, maybe try different embedding models, maybe try different splitting methods, maybe try different retrieval methods, and compare how these perform with different architectures.
Cool. That's really great. All right. So that's great. So that is actually the last session. I want to thank you very much again for taking the time. It was excellent. And I'll just leave it with saying that we will gather up all of the information. We'll send it out to the mailing list. And yeah, until the next time. Thank you so much. All right.
See you. Thank you, Rachel.
Bye.